Let's do some graphs of antiderivatives. Here, what we want to do is, given a graph of a function f of x, sketch the antiderivative, the graph of the antiderivative capital F of x equals antiderivative of lowercase f of x. So let's start with some examples. We can have, for instance, a jump function. Okay, that is 1 on the right and -1 on the left. Okay, so this would be our f of x. And then, of course, here a possibility would be, let's do it here on the right. So when we take the antiderivative of 1, what we get is x plus c. And when we do the antiderivative of -1, is -x plus c. Okay, that we know. But we can also realize, well, if this is the derivative of the original function, that means that the derivative is constant. Okay, that means constant slope equal to 1. So we realize it should be something like this. Okay, absolute value of x. Okay, this is one possibility. So it's x on the right of 0 and -x on the left. But I'm saying it's one possibility because we could choose different values of the constant, right? So instead of this graph, another option would be just, let's shift, okay, this graph, this graph, and we could do something like this. Just a vertical shift. Okay, we could take x plus 1/2, x minus 1/2. Okay, minus x minus 1/2. Okay, both are possible antiderivatives. And both are okay. When we take the derivative is not going to see the vertical shift, the constants. Okay. Now, of course, we tend to think about the absolute value of x because it's continuous. Somehow looks nicer than the second one, but both are perfectly legitimate. Okay, so this would be example 1. Example 2, we could do something more, slightly more sophisticated. So we could take, let's say, -1/2. Okay. And positive 1/2. And let's say the jump happens at x equal 1 and x equal -1. We could choose the jumps like this. Doesn't matter much, but we can totally do that. So this would be 1/2. Okay. So what can be a possible antiderivative in this case? So here we need to keep in mind where the jumps are and then realize, well, okay, the slope is 1/2 after 1, so it's going to be a straight line with a slope 1/2. Okay, and it's the same thing before -1. Okay, so we could put, it can be anywhere, okay, because the vertical shift that we were saying before. So let's put it somewhere that is not very obvious. Let's say here. Okay, and then in the middle we have, between -1 and 1, we have a negative slope that is -1/2. So will be something like this. Okay, so this is 1/2 of x plus c1 plus the negative 1/2 x plus c2 and 1/2 of x plus c3. Actually, I'm realizing the way I have sketched it, then c2 needs to be 0. Okay, so no c2 because it crosses the origin. Okay, but again, any vertical translations of these are going to give you a valid antiderivative. More options. So let's take the antiderivative of the absolute value of x. Okay, we can take multiple antiderivatives the same way we can take multiple derivatives. So here we have the axis. And here maybe we want to, we can do geometrically or we can do with calculus. So here, absolute value of x is a straight line, right? Just a different slope on the left and on the right. But something that has constant slope, like this case x, must come from a parabola, okay? So you have absolute value of x, that is x if x bigger than 0, negative x if x less or equal than 0. Okay, so when I take the antiderivative of x, I get 1/2 of x squared plus c. And when I do negative x, negative 1/2 of x squared plus, let's call it c1 and c2. Okay, so you see the parabola there. So it's going to be, for example, this parabola here, x squared over 2. Okay, that could be one possibility. In this case, we are choosing z1 equals 0. But then I could do, for the left, I could do negative x squared over 2 plus c2. Okay, and that means that I can choose the origin, or I can go a little up or a little down. It doesn't, all of them are good possibilities. Okay, so I'm going to put it here. Okay, so you see there are different options.